Good morning, ma'am.
Good morning, sir.
Good morning, ma'am.
Good morning.
Pradeep?
Hello. Hello.
Hello?
Hello.
Yeah, this is Pradeep.
Yeah, okay. Kindly show your face now.
Oh, yeah, sorry.
Kindly turn on it. Yes, sir.
Oh.
So please switch on the cameras for 5 minutes. Shall we start now?
Good morning.
Good morning, all.
Morning, ma'am.
Good
Good
morning.
morning, ma'am.
How are you, Pradeep?
I'm good, ma'am. How are you?
Very happy to
Long
see you
time.
after a long time.
Yeah. Happy to see you guys too. Yeah.
Okay. Happy to
I
see
was-
about your achievements also.
Thank you. Thank you so much.
Okay, congrats
How's
to
everything?
Pradeep.
Thank you. Thank you. How's everything there? This is the first time I'm actually joining a conference call
Yeah.
with students.
I think you were the 2011 batch, no? 10 years back.
Yeah.
Okay. I think 8th semester you took embedded system elective, no?
Yes, I did.
Yeah. Okay.
How are your friends?
Yeah, everyone is doing good. So I think a couple of my friends. They're all here. They're all my neighbors. So
Okay.
yeah. So I've been in touch with everyone. Most of my friends.
Very good, very good.
Hello, sir. And then
Yes.
Murugan. Yeah. How are you?
So you'll see a lot of new staff. Only few staff will be known to you.
Yeah. Yeah. There are new.
Ramesh Senthil Murugan, so only few staffs are there.
Yeah, Ramesh sir was there for me. Sandhya Murugan sir was there for me, and then I think Marirajan.
Marirajan.
Yeah, you like know.
Yeah, Subhashini ma'am, I think.
Yeah, Subhash ma'am is here. Nice. Hi, ma'am.
Yeah. His thing is she's having class now, so that is yet to join.
Oh, I see. Okay.
Okay. Ma'am, shall we start now?
Yes, sir. You can proceed, sir.
Okay, ma'am. So, good morning to one and all. On behalf of management, principal, vice principal, HOD, so I warmly welcome Mr. Pratheep Joe, Senior Design Verification Engineer, Intel, California, our VEC alumni of 2011 batch. He is going to deliver the motivational talk for your third year students. Okay, that is for look for a bright future. So, and I also welcome all our department staff in this event. Okay, and finally, I'll welcome to all my dear students in this event. And Mr. Pradeep Joe belongs to class of 2011 from VEC ECE department. After his bachelor's, he worked for data consultancy services as an iOS and Android application developer for 2 years. He then pursued his master's in computer engineering in the US, specialized in digital electronics, where he did his thesis on wireless interconnects for network on chip and published two international reputed journals. Okay, he is now a senior design verification engineer at Intel Corporation in California. So working as industry leading next generation PCIe physical IP design for all Intel client and server products. So he brings with him almost 5 years of mixed signal IP design and verification experience. Okay. He bagged awards along with 10 recognition from team members and managers for quality work and reliability. So piloted a long hauling let's start IP to meet quality metrics in a very short period, which had a significant impact in Intel's revenue. He was rewarded with a pilot award in the team. Okay. So again, once again, I will welcome Mr. Pradeep Joe to deliver the motivational talk. Now the session is handed over to Mr. Pradeep.
Thank you, sir. Thank you
Thanks,
for the
Mona.
introduction. Okay, so I think that was a good introduction about me. So in my words, I just wanted to say some few things. So I've been with Intel for the past 5 years, and as the professor said, I did my master. I did my bachelor's in electronics and communication in the year of 2011, and then I did my master's, and from there I joined Intel. So it's been almost 10 years of journey. So with that, I just wanted to give some feedback or like some motivational guidance for people here with I think third year of class ECE. So just wanted to give some guidance on what can you guys pursue in terms of your career and what it means to be an electronics and communication engineer in your future career paths. From here, let me share my presentation. So it says only meeting organizers can present and share, so I'm not able to share my screen. Can you grant permission, sir? Ma'am?
Yes, sure.
Yeah.
Are we given permission, no? That's why I make
I am not able to share. Or is it possible for?
Wait.
Oh yeah, no, it's. Yep.
It's coming up.
Yeah, it works. Can you guys see my
Okay.
screen?
Yeah. Okay.
A minute.
Wait. I think it will be coming. Yes, visible now.
Okay.
Yeah.
Right. Okay, so I wanted to give some good understanding about what you should be taking away from your bachelor's and how that helps you to pave path leading to your core or dream jobs that actually helps from your learnings through your 4 years of your career. So ideally, as this presentation states, get obsessed with semiconductors. That's the main motive. And you can achieve based on some of the guidance that I'm going to be providing from now. So you can get some idea of what to do next and how to focus your learnings uh, for the rest of your 2 years in bachelor's. So the agenda here is going to be my 10-year journey. So to give you an insight about how the 10 years I've been from my bachelor's till the time I'm here with Intel. Just wanted to give you some insight about my journey, and then some guidance on identifying what specializations that you can pursue from your master's in the bachelor's in computing in electronics and communication engineering, and then choosing the right career path based on the specializations that you think that you want to pursue, and then what are the opportunities that's ahead in the industry based on the career paths that you've chosen, and then what lies ahead in the future of computing. So I hope this gives you some insight based on the material that I'm going to be providing and some of the information that I'm providing. So this is just an overview. I'm not a motivational speaker. I am more of a technical person. So I'm going to be mainly focusing on the technical aspects of what needs to be specialized and focused in your bachelor's degree. So, saying on the 10-year journey. So, so when I joined BEC as an electronics and communication engineer, the main guidance that I was provided was it was an easy path or like go choose your paths between a software engineer versus a hardware engineer. You can choose whatever you want to do based on your interests. So basically, I was obsessed with programming and mostly very avid programmer right out of my initial schooling. So I was mainly focusing on programming aspects of it. So I think it was in my second year when I was exposed to some of the inter-college competitions that held in Anna University. I expressed some interest in doing the robot, building a robot for a line tracer event. So that's when my motivation kicked in for electronics and programming. So I did not win the competition, but ideally I was the seventh. I was in the seventh position. I built a line tracer robot which actually completed the maze. So that was my first stepping stone towards what I wanted to do in my future. So that gave a very good exposure on embedded systems, and I wanted to see because I was mainly focusing on programming. I was the embedded systems was like a marriage between hardware and a software. So you can ideally program chips to do what you want to do. So that was a good starting point. Right from there, I completed my bachelor's, and then I ended up in TCS as an Android developer. I did not pursue my core jobs or like core companies. I was not exposed to what was available and what were the opportunities that was available at that point. So I had to go into TCS as part of the campus recruiting. I joined TCS, and then I was working there as an Android developer and an iOS developer. I was app developer. So during that period of time, I was mainly uh, thinking about what am I doing. I studied something in electronics, and I am doing something in the app development. So I was mainly uh, interested in electronics, and it was something that I wanted to explore because I was already basically a decent programmer. I was not really doing justice for what I did in my bachelor's. So I wanted to explore from an electronics perspective what are the applications that I can work on? What are the real world scenarios that I would be working on from an electronics and communication perspective. So I decided to do my master's in the US. I applied for colleges from there. I quit my job in TCS, and then um, I had to do something related to my bachelor's, pursuing in the field of electronics. So I did my master's in computer engineering, mainly specializing in digital systems and digital electronics. So I focused mainly on the digital side of aspects. So I was mainly curious how ones and zeros translate to everything that we program. So I was ideally uh, mentored by very good professors and good uh, experience with real world scenarios like projects and assignments every week. So it was mainly a very practical oriented experience that actually helped me gain the knowledge from from my bachelor's, what I left from my bachelor's, and continued in my master's. So it was really a very good experience where I actually learned the entire working of a computer or like a chip or anything that actually powers the entire world. So I was guided by some of the professors uh, to do my project on a single chip to develop on the digital signal processing side of things. So I had to code some of the chips and then realize them in or simulate them in some of the tools that's available, and then see the output from that. So ideally, you could see the entire process of how a chip can be realized and can be used for certain applications. So from there, I had a pretty good knowledge. I applied for jobs, and I actually ended up in Intel, uh, uh, which is one of the leading semiconductors in the world, semiconductor producers in the world. So it was a dream job, and finally, I thought I had achieved something, and then got into Intel, and then it was an entirely like a new experience to me. It's more of a real world scenarios that you face when I started working with Intel. I was mainly mentored with a very good designers and good architects. So I had a very good exposure towards Intel's architecture and the chip design process. So from there, I moved on, figured out what needs to be done, and then to be focusing on certain aspects of the Intel chips. So I am currently and will be working on the I/O chips, which is the Intel output chips, which is mainly focusing on the communication between one peripheral to the other peripheral. So it involves many protocols. Mainly, I'm working on the PCIe protocol. So if you, for an example, if I have to the RAM that you attach to your computers that communicates through PCIe protocol, and anything that has USB, say HDMI or DMI or anything that actually transfers signal from one entity to another, it uses the I/O chips. So I am currently working on those powering those I/O chips, transferring those data from an analog to a digital world, and then processing those data, and then computing that in the microprocessors and other chips that the Intel provides. So from there, from now, I have some future plans to actually focus on the innovation side of it, and then mainly architecting some of the AI, which is the next gen artificial intelligence and machine learning chips. So they are the future, and that's those are the chips that's going to drive the next generation products. Anything that's from autonomous vehicles, like image processing, and every other real world things, which we are solving with other advanced algorithms. So it really needs more computational power. So the machine learning chips and the artificial intelligence is going to power those machine learning chips. So that's what I'm going to be focusing on from now on. So this is my journey for the past 10 years, and it's been a really a learning experience for each and every step. So that's what you need to have as you grow right from your bachelor's. Identify what things you need, and then focus your learnings towards that to achieve certain goals. So from there, I wanted to switch gears to help you guys understand what specializations that you can pursue from your bachelor's in electronics and communication. So so you can, as far as I know, there are maybe many paths, that many specializations that you can take, but I'm going to be mainly focusing on the core of electronics and communication. So you have two paths: either take digital side, digital electronics, or the analog circuits. So the future, the job, any company, any company or any other core product companies that's going to be focusing people to work on the digital or the analog circuits, or it's going to be a blend of both. So the main aspects that you can focus or to understand to focus your future job roles, you can try to specialize, identify if you want to do a digital side of the electronics, or the analog side of the electronics. So digital side has the digital signal processors, and then VLSIs and computer networks. So digital signal processing is a career on its own. it has a signal and image processing algorithms. You go code or actually design chips to process these specific applications, which process images and all analog signals, any real world signals like the speech that we deliver, everything that gets converted to some digital data and it's getting processed and transmitted. So those kind of chips needs to be developed based on those processing signal processing algorithms. So here you would see, you would have at least heard about Fourier transform, C transform, and all those digital different signal processors, signal processing algorithms. So you need to focus on those if you want to pursue your career in the digital signal processing field. So try to identify what excites you, and then try to focus, or like not focus, I mean try to identify or like dig more in those areas so you can identify if that's actually your future career path. Next is the VLSI. VLSI is integrated circuits. So ideally, any chip that you see is going to be VLSI based field. So it's mainly focusing on digital systems, digital aspects, which I am majoring on, or I specialized in. So I specialized in digital systems and VLSI. So so those are kind of like you write high-level programming that gets converted into gates, and those gates are realized as transistors, and then those transistors get fabricated in those chips, and those chips are put in the PCBs or like the motherboards, and then those get powered as a whole system. So as a VLSI or a digital system designer, it's my day-to-day job is going to be like realizing logical functional aspects, or any logical algorithms, coding them in Verilog, and then those Verilog code gets converted into logic gates. So those logic gates are then realized as transistors, and those transistors is the one that stores the binary data. So my day-to-day job is more like a programmer, but it's coding logic gates, realizing logical functions. So that's one path that you can take if you are more into coding, as well as understanding the underlying logic gates and transistors that realizes your logic. So that's a path that you can take. The next one is the robotics and embedded systems. So as I started talking about the embedded systems in the beginning, it's kind of like a futuristic field. Mostly embedded systems is like the whole world is moving into autonomous systems. People want to produce a lot of products. They have a lot of automation that has to be in place. So embedded systems plays a really good role there for autonomous products. So robotics is also another field within the embedded systems where you can have fun programming and makes realizing your code turn into like robots and automatic systems. So that's a fun field and a very futuristic. So the next is computer networks. I'm not an expert in computer networks. I did a few protocols, communication protocols on computer networks and whatnot. So it is again another field that you can take, which has different network topologies. You have network support roles, and it's also morely like communication related in the digital aspects of it. So computer networks is another field which you can pursue. So with respect to analog now, it's a very restricted field, which only lets you design aspects of the real world scenarios where you have analog signals that needs to be processed and filtered and processed for the digital system to analyze it, digital system to process it. So its main application comes into communication systems. So you can either design analog models for digital systems where you don't really code or like design circuits. You code analog behavior. So there is a career path as such for that, where a digital system relies on analog signals. Then we need to have certain analog models to process that first, to validate or like to handshake with the digital systems. So your career path with coding knowledge and analog expertise would give you a job where you can design analog models for digital systems. Next is for designing the actual circuits. So you have to figure out how to write analog circuits for a specific gain and resistance and filtering logic for different analog signals. So this has an implication in the signal processing as well, and some of the communications where antennas and anything that has analog as an input. So you could choose that as a career path. So this is kind of like a core specializations that you can choose after your bachelor's to pursue your career. So this is not just the things that you have to focus. These are all the different aspects that we have futuristic prospects for. So you have other mathematic based problems that needs to be solved, which goes hand in hand with with all these specializations. So you have to have probability, statistics, and other mathematical problems that has to be solved along with these applications. So these are just I just put this for you guys to understand what's there. What are these specializations that you can, if at all you decide to pursue your master's?
Pradeep?
Yep.
This is Vashni once again. Are you
Yep.
sharing the slide?
Yes.
Pradeep, can you hear me?
Yeah, I can hear, ma'am. Yes, I'm sharing the slide.
No, ma, it is there in the first slide itself. It is not.
Oh, wait. So are you not seeing the slide change?
No. When you are talking, no, it is completely different from what it was displaying. Can you just move? Can you just check?
I am in the specializations slide. Can you see
No.
that slide?
No, it is not being shared.
Is it the same with everyone?
All have the same problem, sir.
Yes,
I
Pradeep.
see.
Are you using two different devices?
Yes, I am. I mean, I'm using two monitors.
Two logins. Are you using two logins?
No, I'm using two monitors. I don't use two logins. I only have one login. So what is that you're seeing?
Pink and
We are with your first slide itself, Pradeep.
Oh, really?
Yeah, we are with your title slide only. We are.
Let me unshare and share again.
Yes.
take control. Take control.
Can you guys see the screen now? Can you guys see the slide?
Yes. Yes.
Okay.
Hello?
Now visible. Now visible. Okay.
Now it's visible?
Yeah, it's visible.
Okay, so you can see, did you guys not see all these slides? Hello?
Pradeep, now we are not able to see your any slide. It is not being shared.
Oh, I don't know what's
Now
happening.
it is. Now it's okay.
Okay.
Just go to slide. Yeah, now you go to slideshow mode and you just project it. Now we are
I
able
did
to
that.
see your, yeah, agenda slide. We are able to see it.
Okay.
Now again it's gone.
Oh, I think it's with the slideshow. I'm not able to. I think it restricts something. I will go with this. I hope you can see all the slides moving, right?
Yeah, now it's moving, sir. Now it's moving.
Oh, it's fine. Okay, so let
Thank you.
it be like this. Yeah, sorry. Okay. So you guys didn't see all these slides so far? Okay. Okay, so yeah, this the specializations that I was talking about. And from here, I wanted to go on choosing the career that you wanted to pursue, the opportunities that lies ahead with respect to the career paths that you've chosen. So ideally, there are these 5 different career opportunities that's available. That it's a broader aspect from a core electronics perspective, but I think this is what I came up with, all these 5 career opportunities that lies ahead after your bachelor's in computer electronics and communications. So what first is the integrated circuits, where you could be a layout or a PCB designer, where you could be routing all the wires and from the transistors. This is kind of like a snapshot where you get to design the entire chip in a software or in a simulator, where you can realize the entire chip functionalities. All these are logic gates and transistors, the relays to transistors with vias and metal layers. So it's kind of like what gets imprinted in a silicon. So you get to design this as an integrated circuits engineer. As a fabrication engineer, you get to convert this file into an actual chip. You would be in the line assembly, programming these, putting these as an input, and then getting a fabricated output from as an actual physical chip. So just wanted to give you an idea of how a fabrication unit looks like and how your day-to-day job would be if you work as an layout or a PCB design engineer, chip fabrication, or yield analysis. Is essentially you get to see how many defects are there in a chip when you convert into a silicon. So you do this analysis and try to reduce the defects in the chip so the chip works fine after it's been fabricated into the silicon. Next is the digital design. This is my career. On a day-to-day job, I design pre-silicon designs on the simulators, on like the EDA tools. So I use Verilog, System Verilog, C most of the time to code these logic gates, run simulations, look at the waveform, debug, and hope the function, like verify the functionality actually works fine. So ideally, these are all logic gates. You would have designed adders, adders, multipliers, shifters in your lab classes. Ideally, we use those as building blocks and design a specific logic for a chip, and then we verify the logic works in an EDA tool. Next is the computer networks. You could be a protocol engineer, a network support engineer. You could be designing different routing mechanisms where you have WAN, LAN, and other Ethernet. Every other communication protocol that you use, you can run it as you can be in the data center working with the different topologies and supporting, or like you need to have all the data centers working every time. So you ideally have to support the network in which it's connected, and you could take this career. And then the analog design is, again, you have mixed signal design engineers, analog modeling, out-of-chip designs. So mixed signal design is mainly where you have an interaction with the analog signal, you process it, and then use that as in the digital domain, and then process those signals as ones and zeros. And analog modeling is ideally converting those analog signals to digital. You could write a model or write a circuit, design a circuit to do that. So ideally, you have to design these kind of circuits based on the application, based on how the signal has to be amplified or differentiated, reducing noises from analog signals, all those different applications. You will have to design the analog circuits based on the knowledge that you've gained so far in analog circuits. I hope circuit theory, or like those, I forgot the name of the circuit theory, I guess. That would mainly delve into all these small signal analysis and RF filters. So you'll be having frequency analyzers, oscilloscopes to actually tap out those signals and then analyze those signals to see if those signals are as per your design. This is one of these career paths. The next is the embedded systems, where you have embedded software developers, computer vision analysts, and then ADAS programming. So you have so you have cars, which is like getting more smart day to day. You have a lot of embedded software embedded in the in your cars and other. It's like a real world scenario where you could employ your embedded systems. So we have many autonomous companies that's coming up. There is a good future for ADAS. programming, and then computer vision is the next thing where you process images to identify pedestrians like people, cars, road signs, traffic signals, analyzing those and coding for your systems to analyze it and then make decisions based on that. So, and robotics, finally, you have all your manufacturing units have this assembly line where everything is automated, and you have most of the work done by the robots. So you can have you could build those robots to do a specific function, and it's kind of like the next thing that's happening here in all manufacturing units. So these are different career opportunities that I can think of as an electronics engineer. So next is what you need to do, what you need to develop to get into those kind of jobs. So integrated circuits in manufacturing, you have basic semiconductor physics, VLSI, and electronic devices. That's the core of all these. You need to understand how transistor PMOS and MOS works, how much the current dissipation it does. So you need to understand all the basics. Those get involved when you design a transistor to do a specific application. So your fabrication, everything involves this physics knowledge and VLSI knowledge. So focus on these if you're trying to get into these kind of jobs. Digital design, VLSI, obviously, and this is semiconductor physics is basic for everything. So you need to understand that first, and then understand on top of that. So the digital design, you have data structures, VLSI, object-oriented programming, Verilog, system Verilog. All these are all programming languages that we use on EDA tools. Like EDA is electronics design automation. So these are all automation tools which actually takes in your high-level code and converts that into gates and gates, not transistors. The transistors are then, so the gates are then converted into transistors in the layout. So that's a different aspect that's covered here. So one thing I could think of is the edaplayground.com. If you go there, you could code a specific logic, like for example, code a flip-flop, D flip-flop, or like anything like a NOT gate or anything that you wanted to code, and then that gets you can verify that in the edaplayground.com. You could go there, run your own experiments, like get your hands wet with Verilog and system Verilog coding here. So next is computer networking, where you have to get some knowledge on network topologies, network protocols. You have network simulators where you could simulate for different topologies and analyze the quality of service and get those metrics close to zero, or not close to zero, close to no defects. So those kind of computer networking, those kind of knowledge is really required for computer networking. For analog design, you need to focus on small signal analysis, LC, RC filters, differential amplifiers. You have accumulators and all those, everything that involves analog signals that filters out noises. So these are all the basics that you need to understand to get into an analog circuit design role. For embedded systems, mainly data structures, C, C++, algorithms, understanding the ARM architecture, assembly language, and the basics of CPU architecture and its instruction set. So it's more of a high-level programming. So if you're interested in that, so you could choose this path of embedded systems. So going next, what are the opportunities that's lying ahead in the industry? You have different jobs. How to find jobs in core companies? That's ideally the one single question that you might not have an answer for. You can look for jobs anywhere in LinkedIn, in the company websites. You could ask referrals from employees, collaborate with alumni like me for any internship opportunities that lies ahead. You could have some experience with that. The one thing is GATE really works, GATE exams, preparing for that, and that really helps to gain some leverage on grabbing these opportunities. Of course, the master's degree is kind of like the next step if you want to like more focused, more specialized understanding that you want, like especially master's degree in abroad, like in Singapore or in the US or in the UK. You can go pursue master's degree, and there's a hell lot of opportunities ahead. So this, I just pasted a screenshot of Intel's job website where you have where you could go search for all the jobs that's available currently, and you can go and apply there. And these are the leading semiconductors companies that's actually the core companies that we should be working on as an electronics engineer. So you could go to their websites, learn about these companies, what they are actually working on, their kind of technology and everything. So you could gain some knowledge from there in their websites or following the different industry standard journals. So this is, I hope this actually clears out some of the aspects of how you could end up in a core company after your bachelor's or master's. So next, what's the future of computing? So future is we have quantum computing that's emerging. It's really a fascinating field of study that you can go and check, Google about this, and it's really a fascinating thing. Excuse me. And then computer vision, machine learning is a booming field that actually utilizes electronics and communication knowledge, which is really the next big thing of the industry as a whole. So everyone is moving towards machine learning and computer vision. So that in hand acts as an autonomous vehicle. So autonomous vehicles are all powered by computer vision and machine learning. So there is a huge demand for design chips for autonomous vehicles. The demand is not being met currently by any of the semiconductor providers for autonomous vehicles. So the next big thing is kind of like the electric vehicles, where everything is processed by integrated chips. So there is a huge demand for that. There's a huge demand for jobs in turn. So the future is really good for the electronics field. So with that, I want to open up for questions. Any clarifications that you want, so I can clarify. Please, I want it to be like an open discussion, so we can brainstorm anything that you want to talk about that's related to this. Questions?
Hi Anna, I'm Deepan from third year.
Hi, Deepan. How are you?
Fine, how are you?
Good.
I don't know whether I can ask this, but what do you think is the reason that Intel is still stuck at 10 nanometer plus process while competitions are at 5 nanometer or something like that?
Yeah, but I don't know how far I can answer that because it's kind of like an internal thing. So, but as an individual who is very keen about process, Intel has its own methodology of designing the process nodes. So these process nodes have its own complications. So I think it's the path that Intel took towards 10 nanometer was actually yielding very less chips with defects. So very less chips without defects. So the delay for 10 nanometer is ideally because the yield was not good. So yield, in the sense, what I mean is when the chips are being fabricated, the 10 nanometer node, the transistors, there are many defects in those transistors. So as a company, since Intel is a design and manufacturer, the only design and manufacturing company, it has to see how it could do in the market, and then it has to have high yielding chips to actually make some profit. So since 10 nanometer was not giving their profit, they had to delay the process. So I think 7 nanometer and 5 nanometer is going to be on track, but ideally 10 nanometer Intel process node is equivalent to TSMC's 7 nanometer. So the performance and efficiency that 10 nanometer would provide would be equivalent to 7 nanometers. So that's so since the process is complicated, Intel had to face those difficulties in 10 nanometer process. I hope they are coming up with new innovations for 7 nanometer and 5 nanometer. Let's see what the future lies ahead.
Okay, Anna, another question, shall I?
Sure.
We can see that now the ARM processors are hot on track while because Apple is designing their own ARM processors while Intel is the pioneer in x86 processors. What do you think will Intel do in the future while many other companies are wanting ARM-based processors?
Yeah, ARM-based processors are efficient and low power consumption. So it's ideally suitable for mobile applications. So, for example, laptops, phones, and all mobile applications can go ARM, but your data centers or for example, any high intensive, high performance applications are going to be very not very focused on power management. So those chips are still going to be used for those high power, high processing requirements. So Intel has its own market, and the market it would do what it's supposed to do to capture those market or sustain this market. So even though ARM comes up, and then now Apple designing their own M1 chips with ARM architecture, but they have their own limitations in a sense, like it cannot do computationally large large things while x86 does. So x86 is a complex architecture, and the performance is actually better than ARM. That's why it's sustaining, and it has its own applications, right? So that's the reason why Intel is sticking to x86.
Thank you, Anna.
Any other
Students, any other questions? Or else post your questions in a comment box. Dear students,
Come on, you can ask more questions. You should
I
have a
think-
lot of questions.
I think they have no doubts. I think they got clear.
I hope so. Okay, that I'll stop presenting.
Pratheep Joe. So,
Hi, yes, sir.
this is Sandil Murugan. So I have one question.
Sure.
So actually, during your presentation, you talked about only Verilog and system Verilog, right? Okay. So
Yes.
then, what about a VHDL? When compared to Verilog, Verilog A, and system Verilog, okay, is there any opportunities with respect to VHDL programming?
VHDL is ideally not industry standard, so we don't. At least Intel does not support VHDL anymore. It's kind of like deprecated programming language. So anything that was written on VHDL is being converted by tools into Verilog, and then the Verilog is actually used to realize logic gates. So since the EDA tools that industry uses, for example, Intel or like NVIDIA or Samsung, every other companies use industry standard EDA tools from Synopsys and Cadence. So those Synopsys and Cadence support Verilog extensively. So VHDL is not really supported by industry standard tools. So they have moved from VHDL to Verilog now. So that's
Okay,
why.
which means so the students have to focus towards Verilog and system Verilog and Verilog EA,
Yes.
right? Okay,
Yes,
so that
Verilog,
is more than
yeah.
enough, right?
Yes, that should
Yeah,
be good
yeah,
enough.
yeah.
for it.
Because there is HTL, there is a two broad classification. No, one is a VHTL and another one is Verilog HTL. I think you people are studied Verilog HTL, right? Okay, so you
Yes.
learned about VHTL,
I
but it's not that much clear.
Yeah, I started
Some
with
most of the
VHDL.
industries, most of the that is UK based industries are working with the VHTL. That's why I asked, right? Okay, what is the current situations? Okay, whether they are working with VHTL or only Verilog. That's why I asked, right?
Oh, sure. Yeah,
Okay.
that's the reason is the tools. The tools, no one's actually um, supporting VHDL, or like even people who know VHDL is actually very less now. So
Okay. Okay. Thank you. Yeah.
sure.
Thank you, sir. Any other questions? Okay. Hi, Pradeep. In signal processing, the what type of currently using for developing filtering, or are going to create any new filters, or are using any existing filters?
Yeah, we use existing filters. It depends on the frequency filtering that we want. Like we are working on higher gem, like now it's 64 gigs of data that has to be processed. So with PCIe Gen 6. So PCIe Gen 6, the signal filters or the analog filtering that we use is depending on the frequency range that it has to be supported. So any noise filtering, ISI, noise, and everything that gets filtered out with the existing filters. There is nothing new as such, but it's just the way that it gets realized in the analog. It might be different, but otherwise, the basics are still the same. There is nothing different that we are using.
Pradeep, one more question.
Sure.
Actually, yes. So nowadays everybody is working on many core and multi-core processor, right? Okay. So you are in Intel. So what is the maximum core you are developing?
I am not in the core design, but at least I'm in the IP design. So the IP is kind of like the IP that talks to the core. So IP, the IP that goes that talks to the core in my current project is, I think, 16 cores. I'm not sure. I think 16 cores. 16 core CPU is the
16 core is the maximum, right? Okay, this is the current scenario.
yeah.
Okay,
Yeah, that's
so
right.
yeah. Okay, thank you.
Okay. Any other questions? Okay. Selvaraj, sir?
Yes, sir. Yes, sir.
Oh, okay, sir.
Shall I
Now
conclude,
session
sir?
is. Yes, sir. What of thanks, sir.
Okay. Thank you, Mr. Pratheep Joe, for spending your valuable time with us. He is an alumni student to our college, 2011 student. He is now the senior test engineer in Intel Corporation, California. The seniors success practice inspirational one to the juniors. So today our student got a successful student's inspirational speech. It's a very valuable one to our all the students. And thank you, Mr. Pradeep Joe. And also I would like to thank our management, principal sir, HOD madam, coordinator Dr. Uday Kumar sir, and all of our faculty members and students, those who have contributed to make this event a successful one. Thank you one and all. Thank you very much.
Okay, thank you,
so
sir.
much.
Thank you,
Thank
sir.
you so much for inviting me.
Yeah.
For sure.
So this is a very nice session, Pradeep. Okay, it's a very nice session. Especially it is purely core. Okay, pure electronics. Okay, it's
Yeah.
really enjoyed. Okay, that is. I think students may also enjoy that. Okay, so students got an idea. Okay, because if you study the basics or concept of ECE, definitely they might have bright future. And also, what Pradeep told, students are instructed to participate events because he got motivated to attend the work. This and the robot attending the events in a actional event, that is a symposium like that. Okay, so students motivate okay, to participate in actional events, then only you'll get an idea. You will get motivated. Okay, you will get motivated like the Pradeep. Okay, because he got motivated to for the robotics. So that definitely have some bright futures. Okay. Okay, so and students and feedback is there, and kindly click and give your valuable feedback. Okay. Okay. Once again, I thank you all. Okay. Thank you, Pradeep.
Thank you so
HOD
much.
ma'am.
Thank you, Pradeep.
Thank you.
Thank you, Uday Kumar sir.
Thank you,
Thank you,
ma'am.
Selvaraj sir, and all staff and students.
Thank you, ma'am.
Thank you, ma'am. So thank you, Pradeep, Joe.
Thank
Thank you. Thank you, sir. Thank you
Thank you,
all.
Uday Kumar,
It
sir.
was a pleasure
thank
to
you,
meet
sir.
you all after a long time.
Sure.
And yeah, we'll definitely be in touch very soon.
Sure, Pradeep. Sure. Okay.
Yeah. Thanks for the
Okay.
time.
Okay. Thank you, sir. Okay. We'll end the meeting now.